Here, we are asked to prove that the third differential of q with respect to y is equal to 2 tan x cos x. If q equal to x squared y cos x plus y cubed sin x over 3. So how can we find this? The first thing we should do is to find the third differential of q with respect to y. So what is d cube q dy cube? As we all know that the third derivative of a function is the derivative of the second derivative. So d cube q dy is equal to the differential of d square q dy squared. d square cube dy squared is also equal to differential of dq dy. So what is dq dy? The differential of x squared y cos x plus y cubed sin x with respect to y now from this here. Since we are differentiating with respect to y, x squared and cos x are constant. We are only going to differentiate y. Now using power rule, we say differential of a power n is na power n minus 1. Y is the same as y power 1. So applying the power rule, the differential of y raised to power 1 is 1 times y power 1 minus 1, which is equal to y power 0. And anything raised to power 0 is 1. So now 1 times x squared cos x is x squared cos x. Coming back here also, 1 over 3 and sin x are constant. We are going to differentiate only y cubed. So dy cubed dy now using power rule is 3 times y power 3 minus 1, which is equal to 3y squared. 3y squared times 1 over 3 times sin x is 3y squared sin x over 3. 3 cancels 3. So therefore, d cubed dy is equal to x squared cos x plus y squared sin x. Then the second derivative. The second derivative is the derivative of the first derivative, which is this here that we just found. Now starting from here now, y is not here and we are differentiating with respect to y. So its differential is equal to 0. While here, y squared sin x. Sin x is a constant because we are differentiating with respect to y. So differential of y squared using power rule is 2 times y power 2 minus 1, which is 2y. 2y times sin x is 2y sin x. So therefore, the second derivative of q with respect to x is 2y sin x. Coming back to the third derivative of y now, the third derivative is differential of the second derivative. So here, the differential of 2y sin x and 2 are constant, and the differential of y is 1. 1 times 2 times sin x is 2 sin x. So therefore, d cube q dy cube is 2 sin x. So now, recall we were asked to prove that d cube q dy cube is equal to 2 cos x tan x. So that means we should prove that 2 sin x is equal to 2 cos x tan x. So how can we prove that? We know that from trigonometric identities, tan theta equal to sin theta over cos theta, and that means tan x equal to sin x over cos x. So now to prove that 2 sin x is equal to 2 cos x tan x, 2 sin x is the same as 2 sin x times 1, and 1 is also as cos x over cos x. And that means 2 sin x is the same as 2 sin x times cos x over cos x, which is equal to 2 sin x cos x over cos x. But sin x over cos x is equal to tan x from this here. So substituting now, we have 2 times tan x times cos x, which if you multiply them, it will be equal to 2 cos x tan x. And that proves that 2 sin x is equal to 2 cos x tan x. Thank you.